All right, now we have half an hour left. We are now at a point in the workshop where I want to conclude with all the geographic information systems. So I showed you a lot of different tools and data and so on, and now you have to tell me what you want to do, what you can do, and we can probably elaborate on this on Monday or on Tuesday, but it's probably better to do this like personally and we just talk about it one-to-one or something. What I want to do tomorrow is to do spatial statistical analysis, just to give you an overview and that you have like a feeling for what's important and what's possible and what's not possible. Now, because we have now only half an hour, I would start with some basics, and then I would conclude this half hour for those of you who are not familiar with Data, just showing you the basics of the program. So this has nothing to do with spatial statistics or geographic information system or spatial data. It's just the basis for what we are doing tomorrow, so that we are not tomorrow needing hours till everyone is on the same speed. So that's something I think is better we do today, because now it's already late and people are a bit tired, so this is the perfect time to do this kind of boring stuff. Okay, but I probably tell you something about, I start with some slides because otherwise we are really a bit late in our schedule. Okay, what we do now and tomorrow is first motivation, then what's with the distances between observational units. We already calculated it, but we have to use it for our spatial statistical analysis. Then I will give you some examples and show you how you can analyze spatial dependence. Okay, as I told you also already yesterday, the motivation why we do this is that it's not only about like painting nice pictures, but it's also about the potential of more adequate statistical analysis and maybe even asking you research questions. And what we also asked yesterday is, in what ways does space determine or influence social phenomena? And this is firstly because actors influence each other, and spatial distance reflects this potential. And this is exactly what's at the basis of all spatial statistical models, that all actors influence each other. And then this is the first reference in all of those spatial econometrics literature. Tobler's first law of geography is all things are related to each other, but near things are more strongly related. This is the core idea of this. How you define this distance, whether you do like Euclidean distance or Manhattan distance, or you insert some kind of network values, network measurement in your distance. That depends on what kind of research questions do you have. So in this regard, space can influence social phenomena by several mechanisms. One, I have to go over it before I give it to you again with the typos, I'm sorry. So one is contagion and imitation, two persons influence each other. One is learning, one or two learn from each other. Yeah, this is very similar to imitation, but it's a more active process, I would say. The other could be like reference groups. Yeah, so I evaluate my social actions on the basis of the people around me. And third, of course, is externality. So I do something and that influences not only me, but also the people around me. Okay, and thus it seems plausible to collect spatial data and model the mechanisms. So in sociology, this is really new, because in sociology we have usually individuals that we ask some questions, and then we have 1,000 individuals, and then we calculate the distance from each individual to each individual. Then we have a matrix of 1,000 by 1,000, and like only 5 years ago this was pretty tough to calculate. But now computers really improved a lot, and a matrix of 1,000 by 1,000 is no problem anymore. But there are classical analysis of these spatial dependence in political science. For example, they analyze countries, and the most important example is the contagion of democracy. So this is just an illustration, I don't know, 1950, 72, 94, and all the political scientists were very happy when this Arabian Spring occurred. I don't know what they are thinking now, but when one dictatorship fell after the other, they said, okay, look, we told you all along, democracy is contagious. Now it's probably disproved, but I don't know. So this is one example where the exact location of each country to each other is very important. And the other social science that does a lot of spatial analysis is, of course, economy, and it's called spatial econometrics, and they do all this spatial regression stuff. For example, when they analyze the cost of housing, it's called the hedonic model, and they do a lot of research in this aspect. And it's very similar, like from the statistics between time series. We have point 1, point 2, point 3, and this influences each other. Yeah, that's something economists do all the time. But now we have like one dimension more. It's not two-dimensional, it's three-dimensional. That makes it more complicated, but mathematically it's very similar. You have lag variables, and you have problems of endogeneity, so you have all the same problems and the same solutions than you have in normal econometrics. Because spatial data is not only like points in time, but points in space, and this is, of course, it's two-dimensional, but it's one dimension more than a time series. Okay, spatial analysis account for the relative position of all units with regard to all other units of observation. This is the important point. That is, the basis of all statistical methods is a distance or adjacency matrix. Distance would be the distance between each and every observation, and adjacency would be just the information whether these two objects are adjacent to each other. That means they share the same border. For example, when you analyze neighborhoods or when you analyze countries, then you have an adjacency matrix.
So here it means just binary variable.
Yeah,
right?
Then you would have binary variables, but you can also like use the length of the borders.
Mm-hmm.
Then you don't have binary variables anymore. So you can do a lot of different specifications. For our purposes, distance is probably sufficient. But I will show you how this works. Okay, spatial statistical analysis allow therefore for the use of more fine-grained analysis than the simple use of spatial variables as context effects. For example, differentiate between East and West Germany. It allows for the analysis of spatial units in relation to each other and not as isolated containers as in multi-level models. And it allows for the specific analysis of spatial processes. That is, you really get, for example, a coefficient for whether the neighbors the spatial neighbors have an influence on the individual, and what kind of influence or what characteristic of the neighbors influence the individual. So there are a lot of different methods, and I will show you a lot of them, and then we will do some spatial regressions by our own, but I will name them here, and then it's okay for today. So there's spatial correlation. The most important measurement is Moran's I, and Moran's I just gives you a measure whether units that are close to each other are more correlated in some variable than units that are more further apart from each other. Then you can do spatial interpolation, spatial regression, you can do geographically weighted regression. There are new measures of segregation that we can use, and as a check whether your normal OLS regression is misspecified or not, you could or should always do this analysis of spatial heteroscedasticity. So usually in an OLS regression, you say, okay, the residuals are heteroscedastic or not, but they can also be spatially heteroscedastic or not, and this violates some assumptions of the OLS regression. This is a lot of words. It's not so difficult. I will show you, and you will all get it, I'm sure. Okay, but now I will skip the next slides because we do it tomorrow. But maybe I can we skip everything. We do everything tomorrow. Here you see, I will show you exactly how it's done. This is really no rocket science. Okay, so now we have 15 minutes left. All the statistical stuff we do tomorrow when we are fresh in our head, and we can start the day with statistics. I hope you are all very excited. Now I would suggest that we at least get an overview of Data. So people who are really familiar with Data or any other program are free to leave, and the others I would ask to open their Data program, as I do here. Nobody's leaving? Okay, but whom of you has already worked with Data? A bit.
We don't use it. We study on SPSS.
Yeah.
Yeah.
Yeah, I mean, there are basically three modern statistical packages. One is SPSS, which is also the oldest and therefore has some problems. And then there's R, and then there's Data, and there are people in the Data camp and people in the R camp. R is open source, which is a good thing because there's a lot of statistical analysis available, but it's also a bad thing that for companies, for example, is open source programs always a bit tricky because nobody is responsible when there's a mistake in the program. So with Data, I think you have a good middle ground between R and SPSS because there's a company behind. You can do a lot of things, and the documentation is very well. So this is really good. But other than SPSS, but SPSS has some syntax as well, but Stata is mostly based on syntax. That is, you write commands in your command window, and then the program does something. And this has the advantage that you can do a lot of things automatically, and you can reproduce it pretty easily because you just copy and paste some commands. It's really easy. Okay, and what we also have. Okay, I show you now the different. No, I would say you type as I type. You can see it. Yeah, I will. Now you see it, right? This is auto. Yeah, no. This is use auto. This just loads up into the program an example data set. It's about cars. It doesn't matter so much. But it will allow me to show you the different features of the program. So, okay. So now we have, this is the command window. I inserted here this command, sys auto, sys use auto. Sys use is systems use, this is a data set that's already in the program. And auto is the data set called. What you have here is a list of all previous commands. That's just for convenience. And it's also for convenience, for the convenience of you, because you can see what commands I type into the command window. I type one command, that's the command. And when you do this, press enter, then you're set. Here, this is the results window. Here you see all what's happening. And it's just this use auto, this is the command, and then he loaded the data. Here you see all the variables that are in this data set. There's a variable for the price and a variable for the weight of the car and so on and so forth. And this is not so important. So this is the whole program of data. If you want to have a look at the data similar to SPSS, you can browse here. You can use this data editor, browse, and then you see all the data as you do in SPSS. There are different columns that correspond to different variables, and in each line there's a different observation, which is in this case it's cars. But we close this again, and we can point and click like this, but we can also write browse or edit, and then the windows goes up. So you can, everything you can do by pointing and clicking, you can also do by writing. And now you see we have two commands. First is sys use auto, and second command is edit. And so now we want to see some basic statistics, and you can use, for this you can use the command summarize. Summarize will give you some statistics. It's always with data, it's always first you type the command. There's a handful of commands that are very useful, and you use them all the time, so you will learn it very quickly. And after the command, you just put the variable where the command is should be active. So when we want to summarize, say, the price of our cars in our data sets, we just type summarize price. And now we have three commands, and we see here in the results window, see the results of this thing. I don't have to make this font larger because you should all have it on your computers. So you see the mean price of the cars in our data set is 6,165, and there are 74 observations, and there's a minimum and a maximum and so on. So this is pretty easy, and you could do it for a lot of those variables. So when you can do this, you can also do everything we do tomorrow. So this tomorrow I will give you a text file with different commands, and we just use the command one by one, and then we see what happens in the program. I will add two other features of the program, and that make one is necessary and the other is makes it easier. There is the possibility that you use scripts or text files that you just save, and you do it with the do file editor. A do file is just a text file which contains syntax, and you open this by typing do edit, and then there's a window open. So, and instead of typing everything all the time in your command window, you can write it here in this text field, text file. You can save this text file later on, and then you can replicate your stuff all the time. So I would write a do file saying, okay, first this use auto. I will make the font a bit larger so that you can see. So this use auto. Then I would say summarize price, and I would probably say, okay, also summarize weight of the car. So now we can run the whole syntax at once. We shouldn't do it like this because now we have already one program, one data set in the program, and when I execute this, here you execute the do file, then I don't even get an error message, but it could be that there's an error message. I would always first clear the data, the program, and then I can just use the auto, execute, and now you see it did everything I typed in here. Firstly, it executed the clear, then it loaded the data, then it summarized the price, it summarized the weight, and that's it. So tomorrow I will give you the syntax file, and we can, and you don't have to type it or copy and paste it, but you simply highlight what you want to execute, and then you do the execution, and then you're done. So, and we could save this now. We don't have to save it. One other thing that is, and therefore it's good that we do it today, because it can be that it's not working right away for every one of you. Similar to R, Stata has some extensions that are user written. So spatial analysis is not on the core of statistical analysis. So people who want to work with spatial data, they wrote some additional programs, some additional commands, like the summarize command, that other people can use now. And these are commands that we have to use tomorrow. So we have to load them into these are really small programs, and we can load it from the internet now, and then we can use the commands tomorrow. So and then they are in your Stata program integrated, and you don't have to care about it anymore. So one program that is no spatial program command, but it's still very important or handy, so to say, is the command FRE, F-R-E, which stands for frequency. And we start with this command because it's just handy to have it. You all should use it, and it's just to show you how it's working. You install it from the SSC archive. Install it, and the command is called FRE. This is all you type, and then you see, and it says to me all files already exist and up to date, but maybe for you it's not. So you need to have a working internet connection, and then everything should work out fine. And these are the programs. These are the 3 programs that you should install now with this command SST install shape2 DTA, SST install spmap. These are the 3 things that you should install. Everything worked? Show of hands, for whom did it work? Or not work? Were still some problems?
On this 3 commands.
These are the 3 commands that we do now. These are 3 commands now. Sometimes they include several commands, so it's just a package.
No, I just mean if we should run on this next lines.
Yeah. That's something I okay, now this is the easiest way to install programs by using the SSC archive. But some of the files are not in the archive. This is the last command that we still need to install. It's SpatWmat, and this is a shortcut for spatial weights matrix. And I try to install it. So, and now this is not in the SSC archive. That means, and it's called, we have to find another way. And when you use the find it command, then you find it here, and you can download it here. You click here to install, and then you're good to go.
Morons.
Okay, I will try it out.
Как это называется? Спот. Все. Да я спатильмат написал.
So these are the 3 commands that you should have installed after today or tomorrow. install the mat.
It includes to the package SQ162.
Okay, so just okay, you type find it. Yeah, well, try it, install and spat mat S P A T W M A T. No, not mat. Yeah. Okay, now you see it didn't work, but you use this right here. Find it. But and you find this one package found, you click on this, and you install.
Thank you.
Very quick, you can tell your neighbor. Did it all work? Yeah. This work. Here in the bottom you see whether it's working or not. Now we need only the command find it, but yeah. This is a different command here. The package is found.
Ну понял. Ну тоже наш такие.
And then execute install. Everything working? Okay, this is the package. Maybe yeah, this is the package that it found. You need to install this package. Click on this link, yes? And then you can click here to install.
It's not the same. It's mine. Not the same.
Okay, what did you find it? Spot mat. You missed the W. Okay, now whenever you are ready, I'm ready, and then I would call it a day, and we continue from this exact point tomorrow at 10:30.
Okay.
Thank you for your attention.
Thank you.
Thank you a lot.
Thank you.